Morning, guys. So we'll be moving on with actually this second last portion or theory portion of your chapter, right? So this one will be having a little bit mix up. Okay. So the topic which we are going to start is in optical instrument. We dealt with what? Remember, we dealt with eye, right? Human eye. Right now, today we'll be dealing with mechanical optical instruments, which is microscope. Right. There are two type of microscopes which you have to learn in this chapter. This is simple microscope and the other is compound microscope. Okay. Now microscope is a device which helps to visualize a smaller object into larger object. Right. It magnifies the object size. Right. You have seen the microscopes in your daily life. Compound biology students definitely would have seen compound microscope, right? It would be having a round setup. You will be having what, a glass material on which you will be taking some pigments, etc., and then you will take some or you will take a blood sample, or you will say to see RBC, or you can even use in botany section you would have studied plant tissues, etc., right? That is visioned using compound microscope. And what do you mean by a simple microscope? That is our common what, common glasses, common convex lenses, right? That is you might be seen that magnifying glasses, right? That some of the people used to see your the lines on your hand. And similarly in some of the shops, in order to see the value of the product, they use a magnifying glass to look at it, because they would be written in short and it cannot be easily seen by even your eyes, right? So so magnification is done by a microscope. That the image is clear. And we have learned two terms. Remember, we have learned near point, which is represented by D, and third one, or the next topic which you have learned, that is that is visual angle. And we had another topic related with visual angle, that is apparent size. Remember, these are all terms we have learned before we dealt with the microscope, or we have learned in what, human eye section, right? Now if you are asked what is the proper equation for microscope's magnification, it is m is equal to, that is magnification of a microscope is equal, for any microscope, simple or compound, is equal to visual angle formed by or subtended by real image whole divided by visual angle formed by object when it is at D, right? Just by heart this equation, that is visual angle which is formed by the real image. That is, you are having an object, right, and that object is kept before a microscope, and an image is formed. If that image is making an angle with the eye, that is known as visual angle, which is formed by the real image. And similarly, the object, when it is kept at distance D, that is our near point, that is the angle which is written in the denominator. Now see guys, let us say we keep the distance at say 25 centimeter, which is our near point for average human being, right? So 25 centimeter is our distance point for almost all the human beings, right? Away from our eye, we are keeping an object at 25 centimeter. There we can see the maximum height of the object, that is, we can clearly see the object when it is kept at the 25 centimeter, right? If we are keeping it 24, 23 centimeter, etc., any one portion of, or any portion of a slight portion of the body even will not be visible to us, right? Now this angle subtended by that object, when it is kept at 25 centimeter, not 25 centimeter, 25 meter, sorry, 25 meter is known as angle subtended by the object at D, right? So m can be even written as beta by alpha, the better than writing the entire sentence, where beta is the angle by real image, alpha is the angle when the object is at D, right? Clear? Now the angle subtended by the, this one is clear, right? What is alpha? when you're keeping the object at 25 meter, let's say here, and this is your eye, so it subtended angle, right? This angle is alpha. Clear? Right? Right, and I have taught that this will be meeting here, right? This will be the apparent size of the image also, right? And you know, see, if you bring suppose you are bringing the object here, so again it will be having the apparent angle will, or the visual angle will increase more than alpha, right? It will be alpha dash, let's say. Similarly, the apparent size will be so large, right? So that some of the part will be outside the retina, right? That's why some of the part of the image is not seen if the object is towards us and it is very near to us by 20 or 25 meters, right? 25 meter is the limit. Clear? Now the angle subtended by that object on eye is alpha. This much is clear when it is at 25 meter. Now if a microscope is used, right, it enlarges the image, or the enlarges the object's image, so that image will be subtending an angle on your eye, that is beta. That is, I am going to redraw the figure again. This is our eye, right? This is the object kept, let's say it at 25 meter from your eyes. Its subtended angle, let's say this is alpha, right? Now an image due to microscope will be formed here, right? This will be subtending an angle. This is known as beta. This is image formed by microscope. This is our proper distance when you are using a naked eye. Clear? And the object is kept at 25 meter. Clear? Now the first type of microscope which you have to learn is simple microscope. Right, it is simple microscope. As I said before, it is a simple convex lens, right? And we have told you it is even used in magnification, right? So it is also called magnifying glasses, right? Clear? So when I draw a simple convex lens, it should be drawn like this, right? This is the principal axis. Let's say this is optic center. Let's say this is a focus, and we are keeping the object between F and the optic center, let's say like this, alright? Then this will be the object size, let's say H0. So one line is parallel, incident ray, then it will pass through the focus at the next side. Another light which is passing through the optic center will be continuing passing on, right? And this is what your eye will be receiving. Now for your eye, these two rays might be coming from another side, right? So you see a virtual image, right? This image is formed due to this lens, right? So this image is what is seen by you. Clear? Right? Now, so you can see that this object, let's say H0, right, is this one. Then this will be Hi, that is the height of the image. Clear? Now I'm going to mark this angle as beta because the angle subtended by the final image, this is final image at the eye. Actually this is the same angle, right? This is the angle which is subtended by at eye, and that means this will be beta, this will be beta. Clear? Right? Now then I can write tan beta, right? Let's see the triangle, guys. I'm going to redraw the triangle in a short way here, right? This is H0, this is Hi, right? This is beta, right? And there is something missing. I have not measured or indicated U, and the object distance etc has been not marked. This distance will be object distance. Let's mark it as UE, because usually this is a piece lens which is near to the eye. You can even write it as eyepiece, right? This lens can be also called eyepiece, but it is significantly used called as eyepiece in the case of compound microscope. I'll tell you how. Anyways, this much clear, right? Now the image is formed here, So this will be what? Our final image, let's say BE. Clear? Now again I am coming back to the point where we stopped. I have drawn this triangle here without any distortion. So I can even, that means this, where can I mark UE? I can write E here. Right, can I write tan beta is equal to, using this triangle, as H naught, not HI, by UE? I can write, right? Clear? I hope this much is clear. Now we know, see, this angles etc. for measurement purposes we are writing it as tan beta. The angle is very small, right? Similarly the object size will be also small. What type of objects we are using for looking through a microscope? You try to look at a small substance, right? So height will be less, then beta will be less, right? So in place of tan beta I can just write beta, that is equal to H naught by UE. Right, this is the angle subtended by the image or the final image at your eye. Clear? It is actually the image subtended by the object also, right, or HO, and the image subtended by the image, both of them, right? If you don't understand, I will tell you, right? Tan beta as per this triangle can be written as HI by VE, right? This will come VE. Now, and also can be written as tan beta is equal to HO by UE. But what you require for magnification is angle subtended by the final image, right? Right, real image, right? So in place of that, it is better for something which is known, because you know where you will be keeping the object and you know what is the height of the object. So it is better to use the angle using height of the object, right? Clear? Because image size can change, right? Now, so beta I have got a formula. Now alpha, it is actually what? The angle subtended when the object is placed at what? At D. So this is your eye, right? This is the object. Let's say it is kept at 25 meter and the object is having HO, right? Then it is alpha, right? Now you understand why I am taking HO, because you have to find a ratio. So you require something in common, right? If I take HI, then I cannot find, see, alpha will be always a constant value and it depends upon the height of the object, right? Clear? I will tell you why. See, tan alpha is equal to H naught by this one will be what? Our distance of near distance or near point distance, which can be written as H naught by D, or in place of tan alpha, since the angle is small, I can write alpha is equal to H naught by D. So alpha is in terms of H naught and beta also needs to be in terms of H naught itself. Clear? Even if you give the definition in terms of image, the equation is in terms of object size, right? Now, what is the magnification of a simple microscope? It is beta by alpha. Now, beta is H naught by UE divided by H naught by D. Can I cancel two terms? Yes. Then H naught can be cancelled, or beta by alpha, or magnification is written as D divided by UE. This is the magnification of a simple microscope. Clear? Now, there are two cases where the simple microscope can have magnification and maximum magnification. So when does simple microscope has maximum magnification? When, see, you know m is equal to beta by alpha and you know alpha is constant. So if magnification has to be large, then beta has to be large, or in a minimum the beta should be equal to what? Minimum condition to become maximum value. That is, maximum value can be 1, right? When can it happen? When beta is equal to alpha, or the angle subtended by the image when it is at what? When does the angle alpha occur? When the object is at distance D. Similarly, when beta can be equal to alpha, when the image is also forming at D, right? That is, when the object, clear? When the object, you know, is at the place minus. Why did I write minus? Because This is as the lens. I have the measurement of UE in this direction. This is the direction of incident ray, right? So object size is minus UE. V is minus D. Okay, similarly then I here also have to actually write it as what? Minus U, right? Right, sometimes you will do that. The problem is, if you keep the object here, the measurement D is also minus. Then it is easy that I don't write minus and minus. So you can write magnification as D by UE itself. Need not write the sign. Clear? Right? Now, here we are going to see what will be the basic equation when maximum magnification is occurring. Clear? And when does the maximum magnification occur? When the image is formed at the near point. Right? Clear? So, object will be there itself, right? That is at UE, and image is at D, right? Minus value. Then I will write 1 by F is equal to minus 1 by D minus UE, right? Then you can just do the calculation, right? Then you will get 1 by UE is equal to 1 by F plus 1 by D, right? Clear? Now 1 by U. Earlier we have written the magnification of a simple microscope is D by UE. Just substitute 1 by UE here, and I can write magnification is equal to D into 1 by F plus 1 by D, right? Or I can write it as M is equal to D by F plus 1, or M is equal to 1 plus D by F. This is the condition, or this is the equation when there is a maximum magnification occurring in the case of simple microscope. Just understand the logic and mug up the equation. Right. Now, once you have discussed about maximum magnification, then of course you have to discuss about what? Minimum magnification. That is a case 2 case. That is minimum magnification. It occurs when, for or during normal adjustment. That is when your eyes are highly relaxed. That is when you are looking at objects at infinity. You are not going to strain your eye. You are just looking, right? That type of case is when the magnification will be minimum, right? If you strain, that is different. Okay, you're not just straining, you are just looking at a long distance, ideally without anything thinking. That is the condition when the image or the magnification is minimum, right? So that means you are looking at a infinite distance, right? The final image will be at infinity. Object is here itself, that is object position is UE, that is minus UE. V will be minus infinity, right? Then 1 by F is equal to 1 by infinity, that is minus UE. 1 by infinity goes as 0, or I can write U, or 1 by UE is equal to 1 by F. Now, again back to the previous equation. What is the magnification of simple microscope? It is D by UE. Substitute this value. That is the minimum magnification of a simple microscope is D by F, right? That is happening at when the image is at infinity, and maximum magnification is 1 plus D by F when the image is at D. Keep that in mind. Clear? Right. So that means I can say magnification of a simple microscope lies in the maximum value between 1 plus D by F and minimum to D by F. That is a range of magnification of a simple microscope. Okay. Now, once you have dealt with a simple microscope, let's talk about a compound microscope. Now, compound microscope is something easy to study because you have learned about combination of lenses, right? Is it straight? No. Let's draw a smaller lens, because the first lens which you see here will be of smaller focal length. Let's draw this one large, right? Now this lens, the first one, and this is the second one. Right, the first lens is near to the object, hence it will be called, object lens. Now this lens, the second one, is close to your eye, hence it is called eye lens, or it is called eyepiece. Okay, And I hope you have heard the eyepiece before, right? Right. So that's why the second lens, this convex lens, is acting as actually a simple microscope. So a simple microscope with an additional convex lens before it is acting or called as what, a compound microscope. Clear? Now passing through the ascendants, I have drawn an axial, right? Let's say the object is beyond f of the first object less, right? That is the, let's say the focus is here, the sorry, focus is here and the object is here. Let's draw the object as AB, right? Now one line, where did it come? One line. Oh, I could have drawn with straight line like this now. Let's change. No. Then I hope I can get straight lines. Right? This is your A. This is your B. Oh, the lens is very small. Actually, the lens is small, but in order to draw the diagram, I'm just making it large. Now, one light ray will be entering, let's say straight like this, right? Then it undergoes a bending, right? It will not bend. Can I do? See what all I'm doing? Man, I'm good. Can I enlarge it also? Let's see. Sorry, I'm taking a lot of time, but I would really want to draw this one. Yes. Happy. But can I rub it off? No. Now, similarly, another line will. Hey, I'm taking a lot of night now, time now. I'll try to do it. Oh, wrong. Better off with the problem. My method. I really tried. Okay. So, anyways, so one light is parallel, so it will pass through what, focus, right, of its own. So let's say this is our eyepiece, right? Let's say its eyepiece focal point is here FE and here it is FE. Let's bring this one very close, right? So okay, clear. Now the image is formed, one is passing through the optic center like this, right, and it meets here. Now let's say this becomes the first image, that is A dash B dash, right? And since we have learned about combination of lens, we know A dash B dash will be now acting as the image, sorry, object for the second lens, which is our eyepiece, right? And the first image A dash B dash, which is formed by the objective lens, is a real inverted and magnified image, as you can see. Right, now just like the previous one light ray will be moved parallel, so that now here the light ray will be passing through the focus, right? Right, and another, let's say, is passing through the optic center. Right, this is what comes to your eyes. Right, so you see that the image is not coming from here. You will feel the image, let's say I am extending it. This will be large, okay, right? It won't be cancelled. This is where the image will be. Okay, why cannot we reduce? See, just to make you guys see the entire image, right? Even if the line doesn't look straight, I meant to make it look straight. Okay, if you want, I can rub this one and I try to make it straight, but I'm sure it will not be straight, right? The image will be very large. Clear? And this is A double dash, this is B double dash. Clear? Right? So this much is clear, I hope. Right? Now, so what are all parameters I'm going to take? This object is placed here. So this is our UO. That is object distance for objective lens. Now, image for objective lens is formed here. So VO, that is displacement, or sorry, the position of the image for, or image distance for objective lens, right? Now similarly, now this is A dash B dash here is acting as the image for the, sorry, object for the eyepiece, right? So this can be written as UE. This much clear, right? Now, so some of the terms I'm going to write here, right? Let's say this is the object, right, for our eyepiece. So let's say this angle is beta. Why? See, this is the actual image that is subtending an angle beta to your eyes. Then if this is beta, then this is also beta. Simple. Okay. Now, now, so just like the previous cases, right, this will, the object size will be h0, right? So keep that like that itself. I have not repeatedly writing it again and again. So let's say the same scenario as the previous one, alpha angle when the object AB is at a distance d from your eye, right? So I can write here tan alpha in place of tan alpha. Since the angle is formed, I will write it as h0 by d, right? Keep this one as it is. Now here in the previous, in this figure, I have a triangle. Let's say this is O, this one is O, right? So I can make a triangle like this, right? Like this. This is beta, this is B dash, this is A dash, right? And this is O, right? Clear? So can I write tan beta? That in place of tan beta, I'm just going to write beta is equal to A dash B dash by UE, right? BO is UE. This is UE, right? Clear? So you got the angle for beta also. But again, listen, beta and alpha, no or no numbers are common, or no factors are in common, right? Clear? Now let's move on with the objective lens. In objective lens, the magnification will be what? V by U is the magnification of any convex lens, or minus V by, or V by U, right? So minus is for mirrors, right? So here I will write V0 by U0, right? See, for the first objective lens, this is your object, right? This is the direction of positivity, and then this is the direction of U0, so it is negative, but image is formed here, right? This is the same direction of the incident ray, hence V0 will be positive. Clear? Right? Right. Now in place of V0, right, or I know the magnification can be also written as H0 by H, I will write it below. In place of magnification of objective lens, I can even write it as height of object by height of image. That is, it is height of object is AB and height of image for objective lens is A dash B dash. So I can write here AB by A dash B dash, right? Clear? Simple. Now that means from here I can write A dash B dash is equal to AB into V0 by U0, that is minus, right? And what is AB? That is the height of the object. It is minus H0 V0 by U0, right? Keep this one, we require this value, right? Now again moving to the earlier values which you have taken, tan beta or beta, I will write it as beta itself. That is beta is equal to AB dash or A dash B dash by UE, right? And we just found the A dash B dash from. And similarly, what is UE? This is the object distance from here, the positive sign. So this direction will be negative. So this beta is actually minus UE, right? Earlier section I have not written. I would request you to write it, or I can write here. It's a beta. Here write it as minus UE. Okay. Now, in case of A dash B dash, we can now write the earlier value, which is minus H naught V naught by U naught divided by minus UE, right? So that arranging and minus removing, it becomes H naught V naught divided by U naught UE, right? Now this is the value of beta which we require, right? Earlier we have already found the value of alpha as H naught by D, right? Now see, both alpha and beta is in the common terms of H naught. Now magnification we know is beta by alpha. Just substitute the value H naught V naught U naught UE whole divided by H naught by D. Now cross multiplication, H naught by V naught U naught UE into D divided by H naught. Cancel H naught terms. I can now write this one as V naught U naught into D by UE. Right, this is the magnification equation for the microscope. And now you know V by U of objective lens, right? This is V by U of objective lens. And this D by U is actually magnification of our what, simple microscope, remember? And I told you the eyepiece acts as a simple microscope. So this is the magnification of eyepiece. And V by U, for any convex lens, V by U gives the magnification. This is for objective lens, so it is MO. And this is ME. So magnification of a compound microscope is equal to magnification of the objective lens into magnification of the eyepiece. Clear? Now, just like the case of our simple microscope, there are some two conditions for a compound microscope, which is maximum magnification and minimum magnification. Maximum magnification, again just like the previous case, when this maximum magnification occurs when the final image is at D, right? And this final image is viewed by our eyepiece, right? Clear? Right. So U will be minus UE for the eyepiece and V will be minus D, right? Now 1 by F is equal to 1 by V minus 1 by U. Just substitute the above values there. That is 1 by FE, that is for eyepiece, 1 minus 1 by D minus of minus UE. Or I can write 1 by UE is equal to 1 by D plus 1 by FE. Right? Clear? So why did I find this one? Just like the previous case, you know the magnification is what? V naught by U naught into D by D by UE. Right? In place of V naught, U naught, you just write it as V naught by U naught. D divided by 1 by UE becomes 1 by D plus 1 by FE. Just rearrange it, guys. That is equal to V naught by U naught 1 plus D by FE, right? 1 plus D by FE. This is the equation during maximum magnification during a compound microscope. Clear? Now just like this one, we can write for the minimum condition, right? Minimum magnification for a compound microscope. And that is happening during normal adjustment, or when I say our eyes are relaxed, or I can say the final image is at infinity. That is V is equal to infinity, U is equal to minus UE, and focus, eyepiece is acting as the lens, right? So 1 by F is equal to 1 by V minus 1 by U. Now substitute this value. 1 by F is equal to 1 by infinity minus of minus UE, that becomes plus UE, or I can write 1 by UE is equal to 1 by F. Now we have found the microscopes, compound microscopes magnification as what? V naught by U naught D by UE. Now in place of UE, you will just write focus. So that is minimum magnification is equal to V naught by U naught D by F. You can write for FE. This is the minimum magnification of a compound microscope. Clear? Right? Mark up the equations. And of course, you have to understand the derivations. Now, here there's another section, that is length of the tube, or said to be length of the microscope, which is the distance between an eyepiece and an objective lens. As you can see from the figure, L is equal to modulus, right? See, V naught from the figure plus modulus UE. Length doesn't have a signature or sign. Clear? Right? Discuss about some of the natural phenomena and some of the things which is done by the prism. Now the prism has a property of splitting the light. Suppose white light falls on a prism like this. Okay, again black light color. Right, this is a prism. If a light ray falls on it, right, it is said that it splits into the components of white light, being here the red and here violet, right? Because red has a maximum wavelength, right? So red has a maximum wavelength means it's having the N minimum, right? And that is refractive index minimum, and it has minimum deviation. Whereas the violet, which has the minimum wavelength, has the maximum deviation. Keep that in mind, right? Now what and all are the property? That is, this was actually found by Newton, right? That is, the splitting of light into its constituent color by the prism is known as dispersion. And after splitting, you get a band of lights, right? Between them there's like rainbow, right? And that is termed as, or the pattern of colors obtained is known as spectrum. Just like electromagnetic spectrum, right? The red light is bending least and the violet light is the most, right? And this splitting, I hope you have remembered the term dispersion. Now causes of dispersion is, right, was explained by Newton. He did an experiment to explain the phenomenon of dispersion. He had first a prism, right? Then a source was kept here, light beam came here, right? Deviated, it split up, right? Suddenly here itself he kept in another prism, so that from here outside what he got is a pure white light again. So white light splitting into constituent colors pass through second prism, again he got a what? Pure color itself, right? These constituent colors, when were allowed to the second prism, that was kept in the inverted position, the result was what? A white light. This experiment proved that it is a property of the prism because of which the white light is getting split up into the constituent colors, right? And they are splitting according to their wavelength, right? And this wavelength dependency is given by Cauchy's formula. Again, it is out of syllabus, I'm just mentioning you. That is Cauchy's formula, right? It is said that refractive index of the prism varies with the wavelength, that is N is equal to A plus B by lambda square. This is the equation for refractive index as per Cauchy. He said that that means refractive index is inversely proportional to lambda square. So when lambda increases, N decreases, that is deviation decrease. Clear? Similarly, when lambda decreases, N increase, hence deviation increase. Clear? This is for our red light, this is for violet. Clear? This and all are common terms which you have to know, or common things which has been taught in your classes or in your textbook. The next phenomena which you have to learn is rainbow. Rainbow. Now there are two types of rainbow which you have to learn, that is primary and secondary rainbow. Rainbow primary is what you usually see, right? That is when the rain is falling, right? After the rain has completely over, there will be still droplets of water in the atmosphere. Then suddenly the sun comes out, right? And the sun comes out and that white light falls on this drop, and this drop will be acting as a reflecting surface as well as a refracting surface, right? Suppose, let's say this is our one drop of rain. So this, let's say, is the incident light, that is sunlight. It falls, right? This sunlight is splitting into two, and we know that red light deviates the minimum. So this is red, this is violet, right? Clear? And here the incident ray, that is at the surface, the angle of incidence is greater than the angle of critical angle, right? It's greater than critical angle, hence it undergoes a total internal reflection and falls here. Similarly, the violet ray also falls here. Let's draw this another way. Violet also undergoes a total internal reflection like this, and this emerges like this, violet, and here red. Clear? This is a natural phenomena. It is based on what? Both reflection and refraction. Why did I say both reflection and refraction? See, here it is refraction, here is a refraction, here it is reflection. So in the primary rainbow section, right, what you can see here is one reflection or total internal reflection and two refractions. Clear? This type of rainbow is known as primary rainbow. Clear? Now, how it actually occurs, that suppose this is the case of only a single raindrop, right? Now there are, say, two raindrops, and this is a small drop and there is another drop like this. Okay, let's draw the sunlight as black color, right? Then just blend it here, internal reflection, right? Length, then it falls on the surface, and then the violet color. Oh, violet looks like a black color, huh? Take this one, blue itself, you will make this understand as violet. Okay, now similarly, let's say the sun ray is falling on the second drop, right? It undergoes a refraction, bends here, total internal reflection, again a refraction, comes out as this one, right? Clear? Right. Now this is only violet rays, right? Violet rays, right? Which had the highest bending. Now along with that there will be red rays also. That is to understand the rainbow section. So here there is a rain, or I can say a red color, right? Clear? Similarly, there is a red color here also, right? Here is a range here like this, and here is a band of colors. This is rainbow. Now in your eye, the first droplets red like this, right? The second droplets blue or violet meets, and this is what is seen by you, right? Clear? This is a band, that is Vibgyor, from here violet, then here to red. Clear? Right? Hope you understood. Right? This is how you see in the case of primary rainbow. Now I told you there is another case of secondary rainbow also. Right? Again we have to draw that. Right? This is a different phenomena, guys. So there are two drops of water droplets. Let's say it is close to each other. Right? Now let's say this is the incident one, and here also incident sunlight. Sunlight is a black one. This is not straight, huh? Okay. Now this sunlight now undergoes here, see, bending here, here also bending here, then it undergoes total internal reflection like this, total internal reflection once, then again twice, total internal reflection, total internal reflection. So clear? And then it undergoes what is, see how many total, one refraction, two total internal refraction, one refraction, two total internal reflection. Clear? Now let's take another color, guys, because we have to show VIBGYOR now. Right. Now this first droplets, say blue light, it is bending, right? So away from the normal, like this. Okay. Now let's say it's red ray also will be there, right? Red ray will be like this, right? This is your okay. I took a red ray. Yeah. Okay. Now similarly, just like this one, there will be red ray from here also, right? There should be a bending. I'm sorry if you don't see a bending there. I can do a small change here just to make you guys understand. Okay. Let's draw like this. Okay. So that I can make sure to and make you understand of meeting. So bending after refraction, this is what is seen by you, right? And there should be a corresponding blue color or violet color here also, right? So this is the splitting. This is violet. This is violet. This corresponding becomes red lines, right? And this is what your eyes see. So for you, first violet comes, then red comes. So primary rainbow, red to violet you say, whereas in secondary rainform you say from violet to red, inverted form. Remember that one. Clear? So secondary rainbow or primary rainbow occurs actually simultaneously itself. When the observer is having his back towards the sun, then he will be seeing the secondary rainbow. Clear?